Assalamu alaikum students. Today we are going to see the practical activity number 11 or the experiment number 11 in new book of first year chemistry, Karachi Intermediate Board of Education. Okay. Activity is that determine the percentage of sodium hydroxide in the given 10 gram per decimeter cube solution of sodium hydroxide by volumetric method. So actually, you are provided a solution in your container, and the solution has a concentration in terms of mass per decimeter cube, 10 gram per decimeter cube. And you have, and this mixture contain sodium hydroxide and NaCl, sodium chloride. So this is the mixture, but what is the amount of sodium hydroxide? We don't know. So we have to determine the percentage of sodium hydroxide. So first we will find the amount of sodium hydroxide. And here the word amount means mole. And after finding the mole, you will find the mass. Okay. So what are the given thing? Given is the 0.2 molar sulfuric acid solution. So it will be given to you with the data. So here the object is not given, but the concentration is not given in the object, but definitely it will be given because you cannot determine without this. So it is also given. So now come. So this is strong acid, strong base titration because we are doing this by volumetric method. In volumetric method, you know, we use titration. So here, strong acid and strong base is there. So the indicator that we use is phenolphthalein. Phenolphthalein, although it change the pH around 9, but because we use the indicator with 2 unit plus minus. So phenolphthalein is the good indicator for strong acid, strong base titration, where neutralization point is pH 7 or the neutralization pH is 7. So what is titration? You have learned it about a lot in different videos, even in my videos on my channel. Titration is a laboratory technique used to determine the unknown concentration of a substance that is called analyte. So what is analyte? Analyte is the substance whose concentration is going to be determined by the help of solution of known concentration that is known as titrant. So here the titrant is sulfuric acid. We know its concentration, it is given here, 0.2 molar. Until the reaction gets completed. How it will be completed? We will see the end point of the titration. The titrant is usually added from a burette to a known quantity. In general, in analytical chemistry, titrant is usually added from a burette to the known quantity of analyte. Quantity means यहाँ पर quantity का मतलब है volume, because in titration we take a specific quantity of analyte here. So what we take 10 ml or 10 centimeter cube sodium hydroxide analyte solution. analyte. And this analyte is the mixture of sodium hydroxide and sodium chloride. So we will see in the procedure right now. So what we will add here, this is the titrant because we know its concentration. This is titrant because we know its concentration. It is 0.2 molar that is given in the chemicals, okay? And it is already given in the object, okay? And this is the analyte and we know its quantity. So usually the material that has the non concentration is added, okay? So the titrant is usually added from the burette to a known quantity of the analyte present in a conical flask. You know, this is the conical flask, and the correct name, although conical name is also correct, uh, it is called Erlenmeyer flask. Erlenmeyer flask, who on the name of the scientist who uh, first invented this flask. So this is the procedure. Okay. Sorry, we will see the procedure first. We are observing the theory, and you should remember these things. So titrant is something whose concentration is known and that is added from the burette. So this is the titrant, and titrant is added from the burette. The reaction between the acid and base involves a neutralization process resulting in the formation of salt and water. So here definitely NaCl will not react, only the sodium hydroxide will react. The chemical reaction of acid and base result in the formation of salt and water is known as neutralization reaction. And then we will calculate the percentage by using this formula. That percentage is the amount of sodium hydroxide present and the amount of mixture. And we know that this amount of mixture is 6 gram per decimeter cube. So we will find it. The amount of sodium hydroxide can be found after the completion of this procedure. So now we will see the calculation. But before the calculation, a student should know the ionic equation for the neutralization reaction. Remember that if we write it in ionic form, so there would be 2 sodium ions plus 2 hydroxide ions in aqueous form. State symbols are required. Plus 2 moles of hydrogen ions. These are also aqueous. Plus 1 mole of sulfate ion. It is also aqueous because both of them are in aqueous condition. So definitely these are also aqueous. On the product side, what are these? 2 sodium ions remain there. 2 moles of sodium ions. And 1 mole of sulfate is also there. And again, it is still in aqueous form. But hydrogen ions combine with hydroxide ions to produce 2 moles of water, and water is in liquid form. So here, which elements have changed their state? Which component have changed their state? So we see here that the component that have changed their state are hydroxide and hydrogen ions. But sodium ions and sulfate ions, they were in aqueous state. before the reaction and even after the reaction. So there is no change, so we can cancel out sulfate and sodium. So what is remaining? Remaining are 2 moles of hydroxide ions plus 2 moles of hydrogen ions that produce 2 mole of water. And writing the state symbol is essential. So this is the equation, ionic equation for neutralization reaction. So this question could be in your Viva. Ionic equation. This is the full ionic equation, but we need only those ions in the ionic equation which has changed their state during the reaction. So anyway, this is up to this. This is the theory and procedure. I have already told you that we fill the burette with the titrant, and this titrant is zero point 0.2 molar sulfuric acid, and we fill it in a way that there should be no air bubble or air even in this jet. This part is called the jet. This is the jet of the burette, and this is the stopcock, or you can use the word tap as well. And here, this is the Erlenmeyer flask or the conical flask, and this is the barrel of the burette. This is the clamp. This is iron rod, and this is the base of the stand. And collectively, these are this is called the iron stand. And how we perform this titration, it is written on the next page in procedure that you will write. Remember that 1 mark is for theory along with the chemical equation and the formula, and 1 mark is for procedure that is written on the next page. But you can write the procedure by yourself. That what you do, you first wash the flask and add 10 ml the given mixture of the sodium hydroxide and sodium chloride, that is called analyte. So we add analyte, 10 ml of analyte, 10 ml or 10 centimeter cube are the same thing. And then we add phenolphthalein. So when phenolphthalein is added to the sodium hydroxide containing mixture, it becomes dark pink. Then you add acid from the burette. So with the passage of time, you will see when you add sulfuric acid into the conical flask, the color becomes fade, becomes light because of the neutralization reaction as the number of OH ion decreases. So there would be the final reading. What is the final reading? I will show it, but definitely there should be a final reading. If you have filled it up to this, then this is the 0 is the initial reading, and whatever the final reading in your practical, I will show in the video. Okay, but now first see the procedure. Procedure is the same thing that I have told you, that fill the burette with sulfuric acid solution, that is actually 0.2 molar sulfuric acid solution of the now if you are writing here fill the burette with 0.2 molar sulfuric acid solution, then you do not need to write this sentence, this phrase. Okay, or up to 0 mark you will write it, because you will fill the burette up to 0 mark. Then take 10 ml. The correct symbol of ml is small m but capital, because the symbol of liter is capital L, so milliliter is the small unit of the liter. Mixture into the conical flask. Add 2 drops of phenolphthalein. You can use 2 or 3 drops, but remember that if you are using 2 drops, then in all the other steps that you will reconduct this experiment, then you will use the same quantity of phenolphthalein. The solution becomes pink. Start titration by adding sulfuric acid solution, that was 0.2 molar sulfuric acid solution, from the burette into the conical flask, drop by drop, while swirling. What is swirling? You will see in the video. Moving the conical flask in round form. This is called swirling. Continue the titration until a pink color disappears. So very carefully perform this, because at certain point, just after adding one drop, that color could be disappeared. Then note the volume of the solution and repeat the titration several times. So the initial reading of the burette would be 0.0, as we have seen here that we add the sulfuric acid up to the 0 mark in the burette. And what is the final reading we will see, but first you watch the video that how we perform this titration. Okay, student. So this is the video. See, we are pipetting 10 ml of analyte through the pipette. See here. So this is 10 ml that we will take. So the 10 ml of analyte has been transferred to the conical flask. Now we will add phenolphthalein here. See, we are adding 2 drops of phenolphthalein here, but I have added 3 drops. Okay, so the color becomes dark pink. Then we perform the titration process. Okay, so now we are adding acid from the burette into the conical flask. See, and finally we have got the end point is very near. Yes, so this is the end point now. So now we will observe the reading on the burette. So now we will observe the reading. If you see, it is 6.1. Actually, this is tilted, and this is not a way to observe the reading. But later on, I found it is 6.1. See, this is 6.1. Okay. When your camera is on correct position or your eye is on correct position, then you will be able to record the correct reading. So the first reading was 6.1 in this experiment, but I didn't use this reading in calculation. Okay. And in one of the reading, I got it, one of the student performed it and he got the first reading on 11.6, I think. So it could, there might be some handling errors or some other errors as well. So this is the object that you have seen in your first page. And this is the way that what we do. We have this solution and we have taken out 10 ml of from this stock solution. And this is the 10 gram per decimeter cube of the mixture of sodium hydroxide and NaCl. So from this, we have taken 10 ml of this mixture that is called analyte. So I should write the word analyte here. This is analyte. Analyte has been transferred. 10 ml analyte is transferred into the conical flask. And then we add 2 drops of phenolphthalein into it. So it becomes dark pink. So it is already pink. I have written here. Then we perform acid-base titration that you have seen in the video. So what we got and what we have already given. The volume of sodium hydroxide was already given 10 ml that we have taken the 10 ml. And butyridine, I will tell you later on. 0.2 molar sulfuric acid, it was the concentration was already given. Molarity of sodium hydroxide, we have to find it. Reacting moles of sulfuric acid, we can see from the equation, balance equation. The 1 mole, if nothing is written, it means it is 1 mole. 1 mole of sulfuric acid reacts with 2 moles of sodium hydroxide. So the reacting moles of sulfuric acid N1 is equal to 1, and the reacting moles of sodium hydroxide is 2, and N2 is equal to 2. And now see, these were the readings. This is it comes under the heading of observation. Okay. So in observation, we started from the 0, and the final reading was 5.1. So the difference is again 5.1 because we calculate the difference by subtracting the initial reading from the final reading. This is the final reading, and the initial reading was 0. So the answer remained 5.1. Then we started our next experiment from the same volume of the sulfuric acid, that was 5.1. And the next reading was on 11.1. So the difference is 11.1 minus 5.1. It is 6. But the difference, and this difference is actually the volume of acid consumed. Volume of sulfuric acid consumed for 10 ml of this mixture, this analyte. Anyway, so the readings are very different. 5.1 and 6.0 is very different reading. So definitely there should be some handling errors, human error. Then we conducted another experiment. Remember that whenever you conduct the next experiment, you must wash the conical flask with distilled water and do not need to wipe it. Okay. And never rinse it with the analyte. Okay. Just wash with the distilled water. So next, the reading was 11.1 already. The burette reading was this. That was the initial reading for this experiment number 3. And the final reading was 17.0. So the answer is 5.9. Although these two results are very close to each other, but even they are not concordant. And in our syllabus, we are instructed to find the concordant reading. So it is still not the concordant one. So we have to conduct one more reading. Otherwise, 3 are enough. But if you do not, if you don't get a proper or the 2 concordant readings, then perform another experiment. So again, we wash the conical flask and perform the 4th experiment, where the volume of sulfuric acid was 17.0 and the final reading was 22.1. So the difference is 5.1. So these are the 2 concordant readings. The 2 concordant readings are this one and this one. So we consider this 5.1 is correct. So 5.1 ml is the correct burette reading. The concordant reading is actually the burette reading. So we have a formula M1V1 upon N1 is equal to M2V2 upon N2 for determining the molarity. So if we consider that this is for the base, uh, this is for acid, and this is for base. So what is there? We know the molarity of acid is 0.2 here. And the volume we have calculated from here, the burette reading, the concordant reading, and one from this balanced chemical equation, N1 is 1. And M2 we have to calculate 10 because we have taken the 10 ml. So 10 is there. And 2 from the 2 moles. So in this way, you got this. So M2 is equal to, you shift the 2 here and 10 here. So what you got, the molarity is 0.204 molar for sodium hydroxide. Now you have to calculate the mass of sodium hydroxide because this is the concentration. So we know that the amount of the sodium hydroxide can be calculated by the formula molarity multiplied by molar mass multiplied by volume in decimeter cube. So what is the volume in decimeter cube? We know that this is 1 decimeter cube. See here. Per decimeter cube is 1 decimeter cube. Otherwise, they must have written the volume of the uh, volume of the analyte. So this is 1. And 40 is the molar mass of the sodium hydroxide. You know the atomic mass of sodium is 23, oxygen and hydrogen. So oxygen is 16 plus 1. So if you sum it, then it is 40. So 40 is this, and molarity we have taken from here. So the mass of the sodium hydroxide is 8.16. After calculation, we got it. It is 8.16. So we found that this 10 ml contain 8 point, not this 10 ml. This flask has 8.16 gram of the 8.6 gram of the sample. Okay. But remember that it was in this flask. So 8.1 was that. And why we have divided it by 10? Because the 10 gram sample was there. So out of 10, it was 8.16. So 8.16 multiplied by 100 divided by 10. This is 81.6 percentage. So the percentage of sodium hydroxide was 81.6%. Okay, so the given sample that was given to us, it contains 8.16 gram of sodium hydroxide that is equivalent to 81.6 percentage. So that was our target. Now see, how will you write the result? So we have done our all this calculation. That was not for us, it was 0.204 for us. And whatever we got, that it was the 81.6%. So it was 81.6%. So our answer is, you will write the result. The percentage of sodium hydroxide in the given 10 gram per decimeter cube of sodium hydroxide NaCl mixture is 81.6%. The safety precautions: rinse the burette with the given sulfuric acid, because It helps us to remove the any water from there. And remember that after rinsing, this content would not be added to the sample of the sulfuric acid given to you. You just discard it. Not the lower meniscus. So you have seen that. We always see the lower meniscus. Conical flowers must be dried. Uh, Not necessary to be dried. If it contains certain amount of water drops, it doesn't harm. I don't know why they have written this, because there the reacting moles are there. So it does not affect if the concentration slightly change in the conical flask, because the number of moles that you have transferred in 10 ml volume, that would be same. So it is not necessary. Be very careful while working with sulfuric acid. Tissue damage, because sulfuric acid is corrosive in nature, so it may cause damage to the skin, or serious burn in case of concentrated one. But 0.2 molar sulfuric acid, not very harmful, but it could be irritant for you. So immediately wash your hands. So we should avoid these safety precautions. We should wear the gloves, goggles, and use pipette filler for pipetting. Okay. So that's all for the experiment number 11. We will see the other experiment as well. And until now, I have not uploaded the activity of uh, activity number 10, that is strong acid, strong base titration. We will see it later on. First, I'm going to upload this video. Allah Hafiz, take care.